All right, let's boogie. So this example is related to trying to integrate everything with regards to kind of circles, line segments, and then points on the Cartesian plane, and then giving you a pretty, I guess, interesting example to think about. Now, in this example, what we're going to try to do is, so you see a circle there. There are 2 points and they're connected, so there's a line segment as well. The circle has an equation, and the question is find the point on the line segment, so joining that P1 and P2, such that it gives the shortest distance from that point to the center of the circle. So what would that point be on this particular line segment? Now we can guess it, of course, but then how do we actually find the point exactly? Now we do need the center of the circle, which we can obtain from the actual equation of the circle, which has been given. Now I plotted the circle for you, so here is the equation of the circle. And then the other question that it asks us is this point the midpoint of the line segment? So those are pretty interesting questions to be able to try to gather them, the information needed to solve it. So let's kind of begin. And now if I want to find the shortest distance from the point to the center of the circle, so we know that's going to be the perpendicular line, which basically will go, in this case, through the center of the circle, and it will attach itself to that line segment, but it has to be perpendicular to that line segment. And in order to do that is I need the actual equation of the line segment, because I'm going to need the actual slope of it. Now, once I find that slope, I can find the perpendicular slope to that, and then I can substitute the center point into that perpendicular line, so I can find the other line, and then I can find the intersecting point between those two lines. So those are going to be kind of the steps that I want to be able to take. Okay, so let's kind of begin. Now from here, so from this equation of this circle, so notice I can see right away that my center, so this is going to be the x value, and then this is going to be my y value. So that is just straight from right here, and this is the equation of the circle. And I can plot that in there, so that's 1 and -1/2, so it's going to be somewhere approximately here. That's my center point. Now, I also know the radius. It's not that the radius is going to be super useful for us at the moment, but the radius is going to simply be, right, so this, and then taking the square root of that, right? Now, if I have my point, which is the center, which is 1 minus 0.5, so that's the first thing, so I have a point. Now I'm going to need some kind of an actual point, so notice I'm going to draw this in here, and then I'm going to kind of swing it around. So we know that this has to cut through at a perpendicular, so at a right angle. So it's going to be somewhere, I'm just kind of guessing, it's going to be somewhere along there. And we want to be able to find, you know, what is this point? Of course, it may not be exactly that point that I'm plotting there, because I might be just a touch off. So let's try to see and find first, so from right here, we're going to be able to find what is the slope of this line, and I'm going to try to find the entire equation of this line because I know the 2 points. So my slope, so first of all, is going to be, so m is equal to, so that's just rise over run in this case. Now notice that it is negative, so it's going to have a negative slope there. And actually the rise over run, just gauging from the points itself, so notice the rise, so that's going to be, so I'm going to take 0.2 minus 0.1, that's going to be that, minus 3 divided by, and then my run, which is going to be 5.5 minus 2, it's 5.5 minus 2, and this gives me my slope, and my slope is negative. In this case, it's going to be 3.5 all over, and notice here it's going to be 3.5. So my slope is actually -1. That's what I have there. Now, the actual full equation of that line segment, so that would have been -1, right? So -1x plus my y-intercept, so that's b. But I can find this y-intercept by just substituting one of those points, this one or this one. I'll take the point number 1, which is 2, 3. It's a little bit easier to work with. So this is what we got. Now I can isolate this for b. So b is equal to, so I can bring this over to the other side, and you will notice that that b is going to be 5. And if I would extend this out, so what I would find is that this particular line, if I extended it out, and I would draw it out here, so it would cross through that 5 right there, that's what I would have. And that is my b. My line, entire line is -x plus 5. So that's my line segment that goes through those two particular points. So that's great. Now, since I want to be able to find the perpendicular line, I'm going to try to take the slope, which is -1, and don't forget. So now if I want to find the perpendicular, so that means that our slope, okay, we're going to take the negative reciprocal of that slope. Well, it's just -1, so the negative reciprocal is going to be just 1. That's going to be our new slope of our second line, and that's going to be just 1. Again, so don't forget, so this is -1 multiplied by 1, which should give you -1 back if you want to have two lines be perpendicular to each other. Now we have our slope, and I'm going to create my equation of the line. That's going to be my second b. Let's plug it in. I'm plugging in my center point right there. Bringing this over on the other side. I'm going to have b -1/5. And that simply means, so it's going to swing through that. That's going to be my y-intercept of that line. And now I have found y, which is equal to x minus 1.5. Now I have my two lines and my original line, which is y minus x plus 5. That's my second line. And now the intersecting point between these two lines is going to be what I am looking for, which is the actual point on my line segment. So it's going to be this point. Now, of course, it may not be exactly there. That's the point that I'm looking for. I'm going to take line 1, line 2, and find the intersection between them. In this case, I can just substitute in, equate the two lines, because they're nicely already in slope y-intercept form. I have these. Let me solve for x. -x, bring this one over, -x, -1.5, bring that over. And I have, dividing, of course, by -2. The negatives cancel, and that's my x value, which is going to be 3.25. Substituting that 3.25 into any of those equations is going to give you your y value. And for that, it doesn't really matter. I can substitute it into this one, for instance. Y is equal to 3.25 minus 1.25. And that's going to give me my y value, which is going to be, I guess, 1.75. And I have found my point, which will be on the line segment, and it creates the shortest distance to the center of the circle. Now let's see if I guessed that correctly. It was 3.25 and 175. 3.25, I guess, almost. It's kind of right there, maybe just a touch higher, but that's what it would have been. Now, the second question, or second part of the question is this point the midpoint of the line segment? Midpoint means it basically cuts it in half of that line segment. And we can check that very quickly. All we have to check is, okay, we can check the x value. Notice if we take the two, and I'm going to be adding them up together, right? So let's say 2, so this is the x value 2, right here, 2 plus 5.5, divided by 2, it's going to give me the midpoint on the x, and that's going to be 7.5, divided by 2, 75. Now notice, we got 3.25. So just checking the x value, we can see that actually the midpoint, it would have been a little bit further. Okay, so it would have been a little bit further. So the midpoint of that line would have been somewhere over there. That's what that would have been. In this case, the answer is no. All right, so notice that the shortest distance to the center doesn't necessarily mean that it's going to be the midpoint of a particular line segment, and that should make sense to you. This is a great example, and it would definitely test your understanding of all of these line segments, points, and circles, and then trying to see what kind of questions your teachers might come up with on maybe future tests or quizzes. I hope that you found this useful, and we'll see you in a future video. All right, so take care. Bye, everybody.